Hello, this is Bob from App Jedi again, here with a very important SQL topic called SQL injection. Very important topic. If you don't do it right, your entire system can be hacked and we lose a lot of data and money. So let's talk about SQL injection. What is SQL injection? SQL injection is a type of security vulnerability that allows attackers to manipulate a website or application's SQL queries by injecting malicious input into fields instead intended for user data. This vulnerability can lead to unauthorized access to databases, allowing hackers to view, modify, or delete sensitive data. So that's kind of the definition of it. Let's take a look at an example of it. So let's say you've got a user login form. We're going to look at the actual form in a moment. They enter a username and a password, and you generate a SQL statement, something like this, using string concatenation. Select star from users where username is and concatenate whatever they entered as the username on the web page or smart device, and same thing with password. So if the user enters something like admin quote space dash dash quote, and then anything for the password, it doesn't matter. The SQL statement that will be executed will be select star from users where username equals admin. The password word is completely ignored. Why? Because dash dash is a comment in SQL. You've dynamically generated a SQL command. That SQL command gets executed as is. Anything to the right of the comment is ignored. Because we put a close quote here for admin, and then a space and a dash dash immediately after it, and then another space, this dash dash here means ignore everything to the right of the comment, which means the password part gets ignored. So all the person needs to know is the username. And that's it. And there's ways to get around that too. Even if you don't know the username, there's ways to get around that. So let's take a look at an example here. Over here. Admin. Ooh, the admin user. I'll put a quote there. Dash dash, another space. Ooh, my server must not be running. So, oh, my server's not running. Okay. Got to run the server. Okay. Now let's try it. Login. User authenticated. What I'm going to do here is I'm going to right click and go down to something called inspect on the browsers, which will let you see what's going on internally on the web page. Console will show things here. And what we're getting here is the post, and we see the response from the server that says user authenticated. Let's go over to the server code here. A lot of stuff here. First of all, let's look at how this is working. We've got API. It's going to the API server, authenticate, or let's look at the login. So when you go to the login, what this thing is doing for the authentication is it's creating an object, a body. Primarily what you have here is just the username and password is all it cares about. It's making an API call from the browser right here to this URL, API auth, and then it's going to get a response back. And I'm console logging the response out, which is, where are we at here? Post login response right here. User authenticated. Okay. So let's take a look at what's going on here. So this thing here says it's calling API auth. So we have to look on our server at the API route. And this is the API route, auth. What is auth doing? It's getting the information from the user, right? The request username and the password. And if we look at here, that's this console log right there. It says the username is admin, single quote, space, dash, dash, space, and the password doesn't really matter what the password is. And this API is going to pass that through to our service layer, auth in the service layer as well. Go to the service layer. That auth is now making a call to the MySQL database. And here it's making a call that says auth underscore bad. And the reason I call it bad is because it's bad. It allows SQL injection. We'll see how that works in a moment. Coming over to the SQL right here. And let's go to where that auth bad is. Here it is, auth bad. What that's doing is that's constructing a SQL statement as a string, in a string, concatenating or embedding whatever they entered for username and password in that string. And now here, this console log, we'll look for this login. It's important. There it is, login right there. This is the SQL same that actually got executed. And let me show you why it works. I'm going to copy that. I'm going to go to MySQL Workbench, and we're going to execute it. And you'll see when we execute it, lo and behold, it gets it. Why? Here's the dash dash. That's the comment. Everything to the right of it, look, it's in a light shade of blue. That means it, oh, SQL says, oh, that's a comment from the developer. I don't care about that. I don't care about comments. I only execute the actual SQL. That becomes the actual SQL. You only need to use a new username. Now, there's other ways to get around this as well. You can say this. You can say, you don't even need this. Well, you probably need to have admin username in there because you want to get admin privileges. So you would do it that way. There's other ways of hacking SQL. If you wanted to, like, just say embed a drop table command in there, that's pretty bad. That too, right? Drop table. We don't want to do that. You could do something like semicolon here, drop table users. I'm not going to execute that. Now, we'll talk about how to avoid this, but it could be really serious stuff. Right. So how do we get around that? Let's go to take a look at that. A couple of ways of doing that. Prior example used dynamic SQL. That's really bad. You should never use dynamic SQL. There's so many problems with it. It's a SQL statement created at runtime using a string and values concatenated into the string. Here are some of the solutions. 1, use prepared statements. We're going to look at that in a moment. 2, store procedures. Always make sure you validate user input on the server side, not the client, on the server side. And also go with the principle of least privileges. Talk about that as well. So first, we'll start with a prepared statement. Okay, this is bad. Here's the prepared statement. And we're going to tell the server to use this one in a moment. This does create a SQL string, but instead of concatenating the username and password into the string, we're putting placeholders, question marks. What happens is that SQL is going to execute this in 2 parts. One is it's going to compile or precompile the SQL statement, and then it's going to replace the question marks with actual values. But those values are going to be put in between strings, or between quotes, and you're going to see that in a moment. So when you try it, it doesn't work. All right. So here, just clear that up. Go back to the service layer. Okay, service layer is using bad. We don't like that. So here, I'm going to change this to PS, which means it's now going to use the prepared statement version of the auth. Let's go ahead and try and run this again. Restart the server. Go back out to here. Log in again. User not authenticated. Boom. That stopped the SQL injection. Let's go down here. Now, what you're going to see in here somewhere, this is the SQL statement that the prepared statement generated. I'm going to copy this right there. It's important. And you can see it's getting it. It's saying it failed, and it's going through it. So let's take a look at it. Now, to show you, all right, now I'm commenting out the whole line. If I click execute, nothing happens. There's nothing to execute. That entire line was ignored that time. I'm going to paste this one in. This is the one that the prepared statement created. Notice everything is between a quotes. That means SQL is now going to consider that entire thing as the username. Those double dashes are part of the username. They're not part of the command. With dynamic SQL, the double dashes commenting it out was part of the command. With a prepared statement, it's all part of the username value. That's why it fails. So if we execute this, nothing came back. It failed. So definitely use a prepared statement. Do not ever use dynamic SQL. It's really bad. It's like I worked in companies. I do code reviews. If one of my lower staff, I was senior software engineer and a solutions architect doing code reviews. If they came back with dynamic SQL, it would be sent right back to them. If they were a junior level person, I probably would just educate them on why they should never use dynamic SQL, and also advise them to demand a refund from whatever crappy university they went to that didn't teach them not to use prepared statements, and not to use dynamic SQL. So someone more senior, boy, would they get their ass chewed out. Okay, so don't ever use dynamic SQL. That's one of the first things I would say. Now, we're going to look at the third way of doing it, which is, my opinion, I think it's the best way to do it, is using something called a stored procedure. So let's go, we're going to go back to the service layer. Now the service layer, I'm just going to remove this part here. It doesn't have anything there because the regular auth is the right way to do it. So service, go back to the, now here for auth, look at what it's doing here. It's just calling a stored procedure. USP underscore auth underscore user underscore auth, and it's passing in those values to it. A stored procedure is a program that runs on the database server directly. We're going to go over here and we're going to look at it. I've got it right down here. We're going to look at it. Here it is. Stored procedure USP underscore auth user underscore auth. It's going to take in a username and a password, and it's going to execute that SQL statement right here. Again, the value of username is going to include everything that typed in that field, including the hack job, as part of the username, not part of the command, but part of the username. So it will fail, right? So we're going to switch to this one here. Okay. We're going to try this again. User not authenticating. Go back to the stored procedure. Stored procedure executed the query, and it checks here to see if it got a result. If it did, show you something else. And one of the reasons you use stored procedures is I'm also inserting a row into a user log that someone attempted to log in. A separate table, user log. Now, then I'm here it failed. So what's going to get returned is this line. -1 as status, user not authenticated as message, the user ID and the username. Now, how does this get returned? All of this gets returned to the server. Let's take a look at that. Here, I'm saying response from database. So let's see, where's the response from database? Should be here somewhere. Response from database. Here, status -1. Go to the database. -1 is status. User not authenticated as message. Here, message. User not authenticated. User ID is 0 because there's no user, so we're just sticking the 0 in there. Right? Yeah, so user ID and the 0, and then the username is there. And you can see the username right there. Now, let's go and look at our user log. So look there, user not authenticated, -1. And there's the username. It's in the log file. This is important because now admins can go and look at the log files and see, was there anyone attempting to hack into our database, into our application? So stored procedures have a lot of benefits. I'm going to talk about them in more detail in another video. This is going to be just about stored procedures. That's coming up soon. Validate user input there, okay? So let's look at this. I have a second version of this stored procedure. Right here. This is doing some data validation. I'm checking here. It says username contain anywhere in the username 2 dashes, or does it contain anywhere in the username a quote? If it does, I'm going to reject it. I'm not even going to attempt to do a search. I'm going to put a row in the user log table. This time I'm giving a status code of -2 and the text SQL injection attempted. And we're returning that to the server. Server's going to get those values. So I'm going to take this version of the stored procedure, and we're going to, I think I just need to add this in here, this if statement into it. I'm going to go to our stored procedure. I'm going to add that if statement. So this is a form of data validation. Okay, now it's still going to say user not found. It's not going to say, oh, you're attempting a SQL injection, because we don't want to avoid alarm or alert. Excuse me, we don't want to alert the hacker. So the message we're going to send back to the hacker is user not found, hoping they'll think, oh, gee, I guess the admin's username is not admin. I'll have to try something else. We're trying to trick them into thinking, oh, the user just doesn't exist. But the code that's getting sent back to the server is -2. So the application server will know, oh, this was a SQL injection, right? So we create this here. So now let's go back to our browser and let's try this again. And now it says user not found. Okay. Oh, gee, I guess the user is not called admin. Let's look at the log file. -2, message, SQL injection attempted. So now the admins can go and look at these log files, and there's also a date timestamp on these log files, and see if someone attempted a SQL injection. It's right there. They're alerted. It's important. Okay. Okay, so now here, we're going to get back to principle of least privileges means is that you give the user the least amount of privileges. And that's important. Let me explain the difference here in the database here. In the case of calling the stored procedure, if someone looks at this code, the only thing they see is you're calling the stored procedure. Even with the prepared statement version, they see the table name. The table is called users. The username column is called username, and password column is called password. So you are exposing some details of your database if someone was able to look at this code. With the stored procedure, you're not. Also, the application is connecting to the database with an application user. That application user has to have, at the very least, read or select access on the users table. However, with the stored procedure, they don't. The application user only has to have execute permission on the stored procedure. It doesn't have to have access to the users table. That's being handled within the stored procedure. So with the stored procedure, the application user that connects to the database has less privilege by using stored procedures. So that enforces the principle of least privilege. Very important. Let's go over here. Here basically is a diagram that just shows how full stack applications work. The client is the browser. It could be a mobile device, an iPad, something like that. It is going to send a request, right? Send a request. If we go back, this login is the request. And right here, this command right here, fetch. Fetch. That sends a request, and the fetch is going to this server right here. So I'm running my local host API auth. That's making that right there, that highlighted text right there is the request going to it. Okay? The server receives that request. That's happening in my API. This auth right here receives the request. Okay? The server, the app server, has to authenticate the user through the database. So it's got to forward that request onto the database. It does that by going through something called a service layer, which is right up here. And the service layer is that now this is where the call to the database is being made. MySQL DAO means MySQL Data Access Object. And it's actually happening in here, where the call to the stored procedure. That's the stored procedure right there. It's calling the stored procedure. So that call gets made to the stored procedure. The stored procedure right here processes it. And then it's going to send a response back to the server. The way to send it back to the server is just using a select command and embedding and putting some information in that select statement, like -2 as status, user not found as message, user ID, p username as username, 0 as role ID. Or if it's successful, 1 is status, user authenticated as message, user ID. And you're going to see that when this comes back, the database here says response from database, right? So if we go down here, we should see it somewhere. Response from database right here, response from database. All those values. In this case, it was a hack attempt or SQL injection attempt. So you see -2, user not found, user ID 0. There's the username, there's the hack attempt, and role ID. And that's exactly what you've got here. This gets sent back, and nicely it's translated in the case of Node and JavaScript. It's translated into a JSON format, which is nice. Other applications like Python or Java or PHP or ASP.NET will also get it translated into something those languages understand. And this can be done with any of those languages. So this response gets sent back to the server. The auth method of the database, the DAO, returns that to the service layer. And all the service layer is doing is returning it to the API route here, gets that back. And then what it's doing, this ctx.body equals rec sends the response back to the client. And in the client, you see down here, this is the response it got back from the server. So that is the entire workflow, client to app server to database, database back to app server, back to the client. That's the entire workflow. It's important to understand this workflow as well, to understand SQL injection, and just if you want to get into full stack development in general, this is the actual workflow. So here we see some signs here. This is the dynamic SQL I showed you. It was really bad. Don't ever do that. So you definitely don't want to do that. There's so many reasons why you don't want to do dynamic SQL. The prepared statement is definitely better. This will eliminate SQL injection. This alone would eliminate SQL injection for the most part. I'm not sure how you would do it with a prepared statement. Best of all, in my opinion, is the stored procedure. It's the best of all. And like I said, I'm going to do a separate video just on stored procedures and why you should use them. There's so many reasons why you should use them. Okay, here's showing the stored procedure right there. Why stored procedures? The database should defend itself. With a stored procedure, the database is defending itself. Here, with this call here, even with the prepared statement, the database is just executing whatever the application tells it to execute. With the stored procedure, the database says, oh, wait a minute, I'm going to make sure you're giving me valid data. And if you're not, I'm just sending it right back to you. I'm rejecting it. So right here, the database is defending itself. With a stored procedure, the database defends itself. It adds an additional layer of security and abstraction. The abstraction is here. You're not telling the hacker, if they're able to get access to this code, much about the database. Sure, you're telling them the name of a stored procedure, but that's all you're telling them. In the prepared statement and the dynamic version, you're saying, oh, here's the table and here's two of the columns, like arguably the most important two columns in a user table, username and password. You are disclosing it. So this adds a layer of abstraction. So you're hiding details of the database here. Even with the prepared statement, you're not really. You're exposing details of your database. You don't want to do that. Protects against SQL injection, absolutely. Reduce network traffic. So let's look at the stored procedure. It's doing a couple of things. It's doing at least two SQL statements. It's doing a search to see if the user exists, but it's valid or not. Even if it is, it's doing an insert into a log table. That's two SQL statements. Now, in the prepared statement or the dynamic one, you could do a second insert statement here to put a log entry file in there. Okay, now you're exposing more about your database, but also think about it. Go back to this design. Server to database and back is required for every SQL statement you execute. So if you have to have two SQL statements, one to look for the user and one to log it, that's two trips back and forth between the server and the database. However, with the stored procedure, it's one. You call the stored procedure executes two SQL statements and then returns to the server. That's one trip back and forth. And you could have transactions that are much more complicated, like you're doing an e-commerce site, where every sales transaction requires maybe 4 or 5 SQL statements. Then you've got 4 or 5 trips back and forth if you're embedding it all in the application code. And also think about how messy that is and how much of the database you're exposing when you do that. With the stored procedure, you're not exposing very much at all. It's a lot cleaner too. It's going to be faster. There's going to be performance benefits to stored procedures. This isn't a stored procedure video. Just kind of giving you, information on that. I am going to plan a full video, maybe more than one, because it's a big topic on stored procedures. Also, can be shared between multiple applications. Let's say you've got diverse clients. You have some clients, some's written in Node.js. Maybe you got another that's used Python or Java or whatever, but they all need to access the same database, right? So now, if you do all the SQL code in the application code, you've got to duplicate that SQL code in, you got to duplicate it for Python and Java, PHP, whatever. You got to duplicate it. But all of those languages are capable of calling a stored procedure. So if you use the stored procedure instead, it's just in the database. You don't have to duplicate this in Java, Python, PHP, Node, ASP.NET. You don't have to duplicate it all over the place. All of those languages are capable of connecting to a database and calling a stored procedure. So now you've got the code in one place, and it's in the database where it belongs. The database should handle all the data processing. Shared centralized data, because I just said centralized data processing. So again, if you've got data processing going on that requires a lot of SQL, that's a lot of traffic over the network. But what if that data processing needs to be accessible from multiple application stacks? You got Node Express, you got Python with Flask or the Django Fast API, you got PHP, ASP.NET, Java, Spring. You got all those frameworks, right? So you'd be duplicating code all over the place. So no duplication of code, centralized data processing. And like I said, I will be producing a full video on stored procedures. Okay, data validation. We talked about the data validation already. That's this if statement. I'm saying if the username essentially has two dashes anywhere in it, the percent signs are wildcards before and after. Same thing, or it has a single quote in there. Then say, oh, this looks like a SQL injection. So we're going to insert a row into the user log, giving a special status -2. The message here says SQL injection for the user log table, but what we're sending back to the user is, oh, user not found. And that's why you're just hoping that they'll say, oh, that user doesn't exist. Let me try something else, basically. If you sent back this message, then like, aha, I got to try something different. No, you just want to trick them, hopefully, and say, oh, the user just doesn't exist, right? Okay. Next thing we're going to look at is alerting the admin with an email. Okay, so we're going to add some additional code into the client side, and this is going to go to the service layer. Authentication, we get this back. And I got the code up here. I just commented it out. What's going to happen here? Where are we at here? Okay, let's put it right there. That's what this says. Okay. So what this says is, if the response I get back from the database status is -2, now the service is going to send an email to an admin. So what's wrong here? Oh yeah, it's going to send an email to the admin, alerting them. SQL injection attempted, right? We're going to try that. And let me go see, get my email open here somewhere. Okay, start it again. Take a look at this log file here. All right, okay. So just started, see, it should work. I'm going to attempt it again. User not found. Here we go. Go back to the database. Okay, it's there. Now, at some point, we should get an email. Might take a little while. It'll take a little while for me to get the email. I should get one. Let's look at the database. What does it say? So much in here. Email sent successfully. Okay. So email got sent successfully. It's just a little delay in getting it, but I should get it eventually. Let's see here. And what else? That's basically it for SQL injection. Very important topic. You got to protect your database. Do not use dynamic SQL. I guess if one thing becomes clear, it should be never use dynamic SQL. Just say no. Always validate your data on the server. The app and the database are both. You definitely use at least prepared statements. Better yet, use stored procedures. Log database access attempts. Let's see if I got the email yet. Yay, SQL injection attempted. I got it. Got the email. So now, you may want to, your admin security may want to act on something like this immediately. You don't want to wait until they get a log report. So I sent an email, SQL injection attempted. So yes, and like I said, I'm going to have a full video on stored procedures because they're very important. Thank you. Please like and subscribe to my channel. I have more SQL videos coming. I have a full series on SQL. You can also go to my website, www.appjedi.net, and let's go there. Right here. Here we go. So here's my website, appjedi.net. In the links page, my LinkedIn, the YouTube channel as well, Reddit, Facebook. I'm usually on LinkedIn all the time. I do provide private tutoring, consulting. I can do classes for corporations as well. So all that. As far as technologies go, I have a lot of experience with all these technologies. MERN only about 5 years. It's fairly new technology. Python, the LAMP stack, Java Spring, over like 15, 20 years, Microsoft.net. So feel free to contact me, leave a comment in the comment section, and more videos coming soon. Thank you very much. Have a good weekend or good